To build out our binary search algorithm, we are going to start by defining it as a function. And we are going to pass in two parameters, a number array and a key. We will be building a binary search algorithm that searches through our list of numbers for the given key, which itself will be a number. If the key is present in our num array, we will return true. If it is not present, we will return false. An important fact to remember about binary search is that the given array must be sorted. So we will assume that any num array passed into our algorithm is sorted by value from least to greatest. Let's also call our binary search method down here with an example so we can reference it as we build the algorithm. Great, so we have our num array here and our key right here is 56. Okay, good. The first thing that we want to do inside of our function is define the middle index of our num array, because we know that for binary search, we split the given array at the middle. So we will say variable middle index equals num array dot length divided by 2, and wrap it all in a math.floor. That will give us the middle index of the num array that is passed in. We also want to define what the middle element in the array is. So we will say variable middle element equals num array at the middle index. Great. So as we know, recursive functions have a base case and a recursive case, or in our situation, multiple recursive cases. Let's define our base case first. So what is the case in which already at this point in our function, we could tell that the num array contains the key we are looking for? Well, we already know what the middle element in the array is. So if that element is the key we are looking for, then we can simply return true. So that is our base case. Let's code it out. We will say if middle element equals the key, then we can simply return true. Great. Now let's get into our first recursive case. Let's deal with the case in which the middle element of our num array is less than the key that we are looking for, like in our example down here. We are looking for the key 56, but the middle element in our array is 36, which is less than 56. So we will say else if the middle element is less than the key and the num array passed in has a length that is greater than 1, then we want to do something in here. And we include this num array.length is greater than 1 part here because if the length of our array is 1, then we only have one element in the array, which is our middle element. And we know that it does not equal the key that we are looking for. So that wouldn't work. So our middle element is less than our key, and our array has more than one element in it. What do we do in this case? Basically, all that we want to do is discard the lower half of our array, since we know our key won't be in there. And then we want to search the second half of our array for the key again. To search the second half of our array, we will be using our binary search function again. So in here, we will write return binary search, and we want to pass in only the second half of our array. We will do this by saying numarray.splice from the middle index to numarray.length. Using the JavaScript splice method like this will give us the second half of our numarray. And now we just want to pass our key into the function as well. Great. That is how we will recursively handle the case in which the middle element is less than the key that we are looking for. Now we do the same thing for the opposite case, the case in which the middle element is greater than the key we are looking for. We will say, else if the middle element is greater than the key and numarray.length is greater than 1, we want to return binary search and pass in the first half of our numarray this time, which would be numarray.splice from 0 to the middle index. And we want to pass in our key as well. And that is how our second recursive case will function. Great. Now we just have to handle the case in which the key we are looking for is not present in our numarray. So we will say else return false. We will only ever hit this case when our middle element is not the key we are looking for and our numarray has a length of 0 or 1. If our middle element does not equal our key and the length of the numarray is 0 or 1, we know that the key is not present in our number array, so we return false. And that is it. That is how our binary search algorithm will function. This algorithm really shows how powerful recursion can be. With just this little amount of code, we can search through a huge array very quickly. If you are having some difficulty understanding what is happening in this algorithm, don't worry. As we continue forward with the course and get more practice with recursion, it will become much more clear to you. Also, I would encourage you to take out a pen and paper and diagram out what is happening in this algorithm with an example. I find that for me, when I am a little fuzzy on a concept, it really helps me to draw out what is actually happening as the algorithm progresses. So I would encourage you to do the same, just as we did in the previous video with the call stack. Let's test our binary search algorithm to make sure that it works in the next video.